going to discuss. Clear? Students, I hope the screen is visible now.
Yes, sir.
Fine. In the previous session, Saturday, we discussed various examples related to three-phase system. Fine. So if you have any doubts, again, we are planning to meet this Wednesday, which is holiday. Fine. And I will share the link, but I'm not sure whether we are going to have a session or not. But a day before, I will intimate you. Fine. Okay. So today we are going to discuss about the digital circuits. Clear. Now we know that there are certain digital numbers are there, which requires the conversion from your decimal number to binary BCD numbers, gray code numbers, then octal number, hexa numbers, and all such things. So whatever you enter through your computer keyboard, which is again converted into hex number, and hex number is again converted into binary numbers. So there are a lot of applications where analog signals converted into digital numbers, and these digital numbers are always having numbers called binary numbers, either 1 or 0. So 1 stands for a high signal and 0 stands for a low signal. Clear? Suppose if we have an analog signal of sinusoidal wave, then this can be represented. Suppose if it is a peak value, can be represented as a peak value. Suppose if it is a 5 volt, then this can be represented in this form also. So this is the peak and this way. So it may be a 0 state or it may be a 1 state. Clear? So all these digital numbers which are converted into binary numbers. Fine. So decimal number are converted into binary numbers, and these binary numbers are having a set of 1 and 0. So let us discuss about 1 byte. 1 byte means are having 8 number of sets of 0 and 1s. Suppose if this is a number 0001 or 0101. So there are 8 different binary numbers where first 4 binary numbers are for one nibble, N-I-B-B-L-E, nibble, and this is another nibble. So a group of 8 bits, these are bits. So group of bits where if there are 8 bits, then there is a 1 byte. 1 byte. Just a minute. So 1 byte is having 2 bits, I mean 8 bits, fine, or 2 nibbles. 2 nibbles. Clear? So these decimal numbers which we need to convert into binary numbers. How? So there are certain methods through which you can convert these numbers into binary numbers. Fine. Suppose if I want to convert the binary number into decimal, suppose if the number is 9. Clear? So this is a single digit that we can represent this decimal number as 9 with suffix 10. Clear? And if we convert this number into binary, then this number is written as 2. binary, either 1 or 0. So it is written like this. So this is a binary number, and this is your decimal number. Clear? So the conversion, that is through the various electronic circuitries. Like we know that various gates are there, various ICs are there. Fine. So that conversion can be done with the help of, even if you look at your computer microprocessor, once you enter either any key, say for an example A, so the ASCII value of this A will be converted into binary because your computer understands only one and zeros. Clear? So in your hard disk, the number of things are added in the different registers of, not register, it's registers of various addresses of memory that is to be added into your hard disk. Fine. And we can retrieve these binary numbers, hex numbers from hard disk, and then we can use similar kind of things for manipulation of data. Clear? So here, let us see how to convert decimal numbers into binary numbers first of all. So decimal number into binary numbers. So here, very simple thing is that we also know that suppose if I want to convert this 8 and 1 number, which is represented as decimal with 10 base, clear? So here if you want to convert this, then there are two different digits, digit 1 and digit 2. Fine. So digit 1, which will be represented by 4 different binary numbers, and digit 8 will be represented by the another 4 bits. Fine. Either 4 bits or one nibble. So there are 2 nibbles in 1 byte. Okay. So here we can represent this number, and directly we can write 1010, then 001. We can write. Clear? Or one more 0 is also there. Sorry, I just made a mistake here. So how to write this number? First of all, let me try to explain. Suppose here you can write 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, and 2 raised to the power of 3 for 1 bit. Okay. Now we know that the number is here 1, here it is 2, here it is 2 raised to 2 is 4, and 2 raised to 3 is 8. Clear? So here we know that the number 1, decimal number 1 is 1 here. So here we need to add these numbers. Suppose if we want to write number 1 here, 1. So 0 plus 0 plus 0, then 1. So this would be 1. This would be 0. This would be 0, and this would be 0. Suppose if I want to represent 8 here, then for second number, again 2 raised to 3, 2 raised to 2, 2 raised to 1, and 2 raised to 0. So for 8, where it comes, so 8, 4, 2, 1. So here we can write this 8 as 1, 4 is 0, 0, and 0. So this is your binary conversion from your decimal number. Are you agreed? Any doubt in this? Anyone? Anyone? Any doubt? Fine. So here we can say this is LSB, least significant bits. This is also known as MSB, most significant bits. LSB and MSB. Clear? So 4 least significant bits and 4 most significant bits. Fine. So we can find this. There is another method which we can use. Clear? Suppose if we have a number, and if we divide the numbers, clear, and if we find the reminders, and if we don't find the reminders, accordingly we can write 1 and 0, 1 and 0. So there are various methods through which we can find this kind of numbers for binary conversion from decimal to binary. Clear? Okay. Now let us have one more example. Sorry. Suppose if I want to convert a number 64 or 63 decimal number into binary number. Clear? So here we know that the least significant bit LSB and MSB. Clear? So here we can write 2 raised to 0, 2 raised to 1, 2 raised to 2, or 2 raised to 3. Or we can write 8, 4, 2, and 1 for LSB. And similarly for MSB also 8, 4, 2, and 1. So here the least significant, sorry, this is MSB. Huh? This is MSB, most significant bit and least significant bit. This is LSB. Okay. Okay. Now if I want to write this 3 number here, then 2 plus 1, that is 3. So 1 will be there, and 8 and 4 will be 0, 0, 0. Clear? And similarly for 6, we know that 4 plus 2 is 6. So 4 will be 1, 2 will be 1, and the remaining 2 will be 0, 0. So this is a binary conversion from this decimal number. Agreed? Any more question? Any question? So this conversion, I think you have studied before, but still it is a part of your syllabus, so I need to cover. Clear? Okay. Now, similarly, we can convert this decimal number, sorry, binary number into decimal number also. So binary number into decimal number. Okay. What is the process here? The process is very simple. Clear? Decimal number. Suppose if there is an example, if there is an example, can we write like this? 1 1 0 0 0 0 1 1. This is your binary number. So if I want to convert into a decimal number, who can help me? Who can help me to write?
So first we'll divide it into MSB and LSB, then
Fine.
that.
So here this is the 1. It means 1 2 4 8. Clear? 1 2 4 8. Clear? So here, what is the total number? Total number is 1 1. Means 2 1. Clear? So answer is 3 here. And what about this? 8 plus 4, 12. Clear? So here we are going to say, for an example, right now you considered only this number. Right now don't consider 1 1. We'll come to that part also. If there is a carry and borrow, fine. So here 1 is there where it is at 88. Fine. So for objective type of questions, this would be very simple to write. Even we can write this with a decimal number also. Clear? So if there is a decimal number here, fine. We can also place the decimal number here also. 8.3 can be written like this also. Clear? So decimal numbers can be converted in this way. Okay. Now one more example. Suppose if we have a number called 110011 binary. Clear? So here there are a set of 3. Clear? Simple way that if it is a binary number, we can also write in this way. Fine. Suppose if it is 2 raised to 0, this one multiplied by 1, clear, plus 2 raised to 1 multiplied by 1, then what about third? 2 raised to 2 The multiplying factor is 0 here. Clear? Then 2 raised to 3, what is the multiplying factor? 0 here. Here there are not 8 digits. That means there are only 6 binary numbers. Clear? So in this case, we can consider this is a whole number, and we can write in this fashion also. So this is 2 raised to 3, now 2 raised to 4. 2 raised to 4. So this is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, now 2 raised to 4. So 2 raised to 4 is also 1. So that is a multiplying factor 1 here. And what about 5? 2 raised to 5, 2 raised to 5, and the multiplying factor is also 1. Here. So here we can have an answer of 32, because 2 raised to 5 is 32, plus 2 raised to 4 is 16. This will become 0, this will become 0, and this will become 2. And sorry, 2 raised to 2, 2 raised to 2 is what? 0, sorry. This one would be 0. So 2 raised to 1 is 2, plus 2 here. Sorry, plus 1 here. Clear? So this would become your number in binary decimal. Clear? So 32 plus 16 plus 2 plus 1. Clear? This is your number 6, 11, and finally it would
51.
be 1. Yeah, 3 plus 3, 61. So 61 is your decimal number. Clear? Okay, now let us move back to another number called octal number.
Sir, 51, no?
Yes, sir, 51.
Let us see. Fine. 1 plus 2 plus 6, 9 plus 2, 1, 11. So 1 carry. 3 plus 1 plus 1, 61.
Yeah, 51.
Sir, 32 plus 16 is 48, 48 plus 2 is 50, and 50 plus 1, 51.
Oh, it's
Yes, sir,
fine.
51. होगा.
Okay, fine. Now here 32 plus 16 plus 2 plus 1. Now check.
11.
So 6 plus 2 plus 2, 10, 1, 11, carries 1, and it is 5. Clear? So it is 5. Okay. Now let us discuss about the octal number. Okay. So there are certain digital circuits which uses octal numbers. Octal number means the base is 8. For binary, base is 2. For decimal, base is 10. Now for octal, the base is 8. Clear? So here, there are number systems which is a base of 8 is known as octal number system. So hence it uses the number 0, 1, 2, 3, 4, 5, 6, and 7. So there are 8 numbers. These digits have the same physical meaning as in the decimal system. Clear? So here we can write 8 raised to 0, 8 raised to 1, 8 raised to 2, fine, and up to 8 raised to n. And similarly, if the decimal number is there, then we can write 8 raised to minus 1, 8 raised to minus 2, 8 raised to minus 3 like this, and 8 raised to minus n. So we can represent this octal number in this fashion also. Clear? Now, this octal number can be easily converted into binary. Clear? Now let us see if there is a number which is given in octal, say for an example 3, 1, 4, and if it is required to convert into binary, then we can convert very simple way. So first of all, let us write an octal number. Octal number, fine. We know that the number is 3, 1 and 4. So here we can say it is 8 raised to 0, 8 raised to 1 and 8 raised to 2. Clear? So decimal equivalent क्या होगा उसका? Decimal here we know that this is the number 3. So 3 into 8 raised to 2 plus 1 into 8 raised to 1 plus 4 into 8 raised to 0. कितना होगा आंसर? Let us find. 64 into 3, it is approximately 192, plus this one is 8, and 8 raised to 0 is 1, so 4. So your answer is 204,
204.
and this 204 is your decimal number. Clear? So 314 base 8 is converted into your decimal number. Clear? Okay. Now octal का equivalent binary number क्या होगा? Let us see. Suppose if your octal numbers are like 0, 1, 2, 3, 4, 5, 6, 7, and what are the binary bits here? Binary bits will be 0, 0, 0 and 0, 0, 1, because we are having a combination of 8 numbers. So there are 3 different binary bits will be in this fashion that we can write 0, 1, 0 for this number. Sorry, I just would like to write it on align with these numbers. Fine. Okay. So 0, 0, 0. Now 1 is 0, 0, 1. What about 2? 2 will be 0, 1, 0. Clear. What about 3? So 2 plus 1. So 0, 1, 1. Clear. This way we can write. This is 2 raised to, binary numbers में हम लिख सकते हैं, that is 2 raised to 0, 2 raised to 1 and 2 raised to 2, 4, like this. Okay. So what is the binary equivalent of this 4? So 4 would be 1, 0, 0. Clear? ये 4 हो गया आपका. अब now 5 लिखना है, तो 4 plus 1, 1, 1, or sorry, this one will be 1. It would be 1, 2 and 4. Here 2 raised to 0, 2 raised to 1 and 2 raised to 2. So we are simply converting these octal numbers, 8 numbers into this binary bits. Fine. Okay. What about 6 then? That would be 4 plus 2, 4 plus 2, 6. And what about 7? 7 would be 4 plus 2 plus 1. So 1, 1, 1. Yeah. We can write in this fashion also 0, 1, 0, 1, then 0, 0, 1, 1, then all 4 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, then 4 all ones. So this way we can convert these octal numbers into these binary numbers also. Clear? So here for an example, if we want to convert 472 octal number into binary numbers, can we write it directly? Yes, we can. So here, first of all, let us try to write 472. We are converting into binary. Now here, with the help of this, we know that this is number 2, this is number 7, and this is number 4. This is number 4. Clear? So we can write this group of binary bits for all different digits. So 2E here. So that would be 0, 1, 0. What about 7? All ones. What about 4? 1, 0, 0. Clear. So here we can write 100111010 into binary number. Is that clear? And similarly, we can consider decimal numbers also. Let's have one example of decimal number. Suppose if the number is 37.12 octal number. Clear? So here we can write 3, 7, then 1 and 2. Clear? Okay. What about 2? We know that it is 0, 1, 0. What about 1? We know that it is 0, 0, 1. What about 7? All ones. What about 3? 0, 1, 1. Clear? And then we can write this number into binary. Is that clear? Any question till now? Okay. Next is binary conversion into octal conversion. Okay. Suppose I have a number, binary number 100, then 111 and 010. This is the binary number. Can we convert directly into octal number? Yes. We know that octal number is a group of 3 bits. Fine. So this first 3 bit is for first, second, and third. So we can directly write it from here. That is 1, 2, 4. 1, 2, 4, 1, 2, 4 here. Clear? So first 3 bits here is 2 because 4 into 0, 2 into 1 and 1 into 0. That is 2 here. What about this number? All ones means 4 plus 2 plus 1, 7. Similarly here 0, 0 and 1 is for fourth number. So that will be 4. So that could be converted number into your octal number. One important thing which you need to be taken care of when you write an octal number, these digits 472, whatever the number is, that would always lies between 0 to 7. That would always be lies into, because we know that this conversion of octal number represents that it is a group of 3 different combinations and there are total 8 numbers. Clear? Okay. Now, let's have an example which you need to convert by your own and then we will move further. Fine? Okay. First of all, convert 117 decimal number to 8-bit binary equivalent binary equivalent numbers. Okay, now practice it and tell me what is the answer. What is the answer?
Sir, is it 001, 001, 111?
See, we are converting this decimal number into octal number. Fine, 8-bit binary equivalent number, and then finally your number that is represented with base 8. Fine, that is fine. As what you said, for number it is fine. Okay, but if you want to convert this number directly instead of 8-bit binary equivalent numbers, clear? If you want to convert from this decimal to a octa, can we do it by a direct method? Yes, we can do. So here, first of all, let us see that is 177. If it is divided by 8, if it is divided by 8, what is the answer here? 22. Clear? And what is the remainder here? Remainder is 1. Clear? Now 22 is divided by again 8. What is the answer?
2.76.
No. I'm saying in decimal 6. रिमाइंडर कितना होगा? ये मेथड आपको पता है, डायरेक्ट मेथड?
Yes, sir. We have to divide by 8. Remainder will be 6.
Yeah. So
And
answer
then
answer will be 2 and remainder will be 6. Clear? So let us try because many of you are not knowing this. So it is 22 here and remainder is 1 here. Clear? Similarly, this 22 number will be divided by 8 again. So 8 duja 16. So there will be two. Answer is 2. And what is the remainder then? The remainder is 16 plus 6, 22. Fine. So remainder is 6. Similarly, this 8 number, 2 number is divided by 8 again. Fine. We know that the answer is 0. And what is the remainder? The remainder is 2. Clear? So we can write this most significant bit and this is a least significant bit. And we can convert this number into octal. So your octal number is 261. 261. So whatever the number you found with the help of this decimal number, fine. उसमें से आप वो decimal number convert करिए and then try to find out that whether this number is okay or not. 261. So your 177 decimal number is being converted into octal number with 261. Sorry, it is 261. Clear? 261 octal. Getting my point? Got it?
Yes.
So try to convert either from binary to octal to any numbers. Fine. So in examination, such kind of small examples of conversions may asked for the solutions. Clear? Okay. Now the next is BCD numbers. What do you mean by BCD? BCD is binary coded decimal numbers. Binary coded decimal numbers. Clear? Now these binary coded decimal numbers where the different circuits and machines can deal relatively with the binary numbers, but people are used to work with decimal numbers. Clear? हम लोगों को वो डेसिमल नंबर चाहिए, जैसे आपका स्कूटर है या एक्टिवा, आपका कार है, वहां पर एनालॉग सिग्नल इज बीइंग कन्वर्टेड इनटू डिजिट्स नंबर्स. डिजिट नंबर्स, वो डिजिट नंबर्स कौन से होते हैं हमारे? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the combination of these three are being represented not in the form of decimal, but it is sometimes used binary coded decimals. Fine. So normal binary numbers are that you can write individually. Fine. But we know that the decimal numbers are always represented in a combination of 0 to 9. So we can write this BCD code for all these different 9s. Clear? And we can have a combination of these three options. Like BCD code is what? What is BCD code here? So we can write BCD code. For an example, suppose if I have a BCD number 489, and if I want to represent this number, we know that various numbers are for this. Okay, what about 9? We can write 9 number with 1001, that is 1, 2, 4 and 8, or 2 raised to 0, 2 raised to 1, 2 raised to 2, or 2 raised to 3. So we can represent this number 1001. Clear? And similarly, we can represent 8. So 8, 4, 2, 1. Now we need to represent 8 here. So 8 would be 1 and the remaining 3 will be 0 because we need to write 8. Then again 1, 2, 4, 8. Now we need to write 4. So this would become 1 and the remaining 3 will be 0. So this is your number. Clear? Now the BCD number has the highest number, which is 9 here, because we know that these numbers are always in between 0 and 9. Clear? So this can be written in the various BCD code. So we know that the BCD code for this is 0, 0, 0 and 0. Clear? We can write this way. That is 2 raised to, sorry. So we can represent this BCD numbers in a 4 different binary numbers, right? So 0, 0, 0 and 0. What about 1? 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3 here. So if I would like to represent 1 here, that could be 0, 0, 0 and 1. What about 2? So this would become 1 and the remaining 3 will be 0. What about 3? So this 1 plus 2 will be 3 and the remaining will be 0. Clear? And so on. So what about 4 here then? 0, 1, 0, 0. What about 5 then? 0. So this would become 4 plus 1, 5. What about 6? 4 plus 2, 0, 0. 7 is 4 plus 2, 6 plus 1 and 0. What about 8? 1, 0, 0, 0. And what about 9? 8 and this one, the remaining 2 is 0. So this is a table which is used for BCD numbers. So these BCD numbers are required many times for this kind of conversions for various applications. Agreed? Okay. Now let's say one example. The example is 24.6. ये आपका जो ऑक्टल नंबर है, this is an octal number. Just convert into your decimal number. Convert into decimal number and binary number. Yeah. So decimal number is with 2 and your binary number is with, sorry, this is with 10 and this is with 2. Clear? So please try to find it out by your own. And in the next lecture, we are going to have various gates which we are going to discuss. Logic gates. Please find it out.
Sir, is it 010 100.110?
So let us try, all the students who are in the meeting, please. So let them try. Done, all of you? Okay. What is the decimal number here? Who will answer this? What is the decimal number here? कितना नंबर आएगा? Would it be 20.75? How many of you got this answer? Sorry, this is 10, हाँ 10. ये डेसिमल नंबर आपके ये बाइनरी नंबर उसमें से आपको कन्वर्ट करना होगा. I hope all of you have received or solved this by your own. Okay, fine. So that's all from my side today. And tomorrow, I think we do not have a lecture, but yes, on Wednesday, I will try to conduct one more lecture, which may be regarding your numerical solutions plus few of these gate and their different circuitries, their different truth table symbols, and their applications we are going to discuss in detail. Clear? So I hope all of you enjoyed this session today. That's all from my side. Any more questions if you have, or otherwise